for. And finally, we have Vitalik come and present a keynote of the day, Path Forward. Please put your hands together for Vitalik.
Okay, so 3 transitions, the path forward. So 2022, right? I wrote this blog. I assume everyone here has read it. Okay. Actually, raise your hand if you have read it. Okay, that's good. Quite a lot of people. So the core idea here, right, that I talked about is basically that there are these 3 transitions that the Ethereum ecosystem needs to go through. I mean, obviously, there's a lot more transitions than that, right? But like 3 particular ones that I wanted to zero in on. One are the layer 2 scaling transition. The second is the wallet security transition. And the third is the privacy transition, right? So the layer 2 scaling transition, pretty simple, right? So back when I wrote this in 2022, it was still like basically defaults to think of Ethereum as being just the layer 1, right? And layer 2 would be something that you would only go to relatively occasionally, right? Now, since then, obviously, we've already seen a lot of progress. A lot of things have really moved on to layer 2s. And there's like lots of applications on, like Optimism, Arbitrum, Scroll, you have Polymarket on Polygon, and like the list keeps going on, and like everyone is, I think, way more multi-chain than they were 2 years ago. The wallet security transition, right? So this is moving from EOAs to smart contract wallets, which solve a lot of important security problems. So who here has a smart contract wallet? Safe. Okay. And who here has or is a member of a smart contract wallet that's not a safe? Okay. That's so. Who here had a smart contract wallet? Let's say 4 years ago. Okay, 2 years ago. Okay, see, so we see this like nice exponential progression, right? 2 years from now, I hope everyone's hand will be up because basically every wallet will be a smart contract wallet. So then you have the privacy transition, right? Which is basically making sure that you have privacy-preserving transfers of funds. You have also other gadgets, especially non-financial things that we're developing, including identity, reputation, social recovery. All of these primitives are also privacy-preserving. Who here has used a privacy protocol? Anything? Okay, specifically privacy-preserving funds transfer protocol, Railway, any of those? Who here has used ZooPass? Any zero-knowledge identity thing? Okay. So hopefully in 2 years, again, this will be everyone. So basically, we're going through these different transitions, and the transitions are challenging because these are not things that can just happen in the background, right? Because they just have hooks into so many different parts of not just the ecosystem, but also the mental models that developers think about when interfacing with the ecosystem, and the mental models that users have when interfacing with the ecosystem, and the interaction between all of these different applications, and even the interaction between like multiple of these different transitions, right? So these are not discrete components that can be swapped, right? This is more like, if you try to swap out from a car to an airplane, right? It's like, no, you cannot just like take out the engine, the wheels and replace them with wings and keep going, and you have like a 1/3 airplane, right? You basically, these are transitions that are just like really like deep and complicated, and there's a lot of hard work that's involved in actually getting them right. So let's talk about what's happened in all 3 of those areas since then. EIP 4844, right? So blobs. So blobs are, the Denkun hard fork, March 13th this year. Since we got blobs, transaction fees on layer 2s have decreased from around 10 to 50 cents all the way down to less than 1 cent. And, I did some math, and according to at least a really basic calculation, even in that time since then, it's possibly saved something like up to $400 million in transaction fees, right? And so it's like we're getting really huge savings, And at the same time, like I think we finally crossed the chasm from Ethereum, the Ethereum L2 ecosystem being something where like you can make toys, you can make expensive DeFi things, you can make $3 million monkey trades, but like you're not going to like actually make like applications that like say help regular people like in Argentina or Nigeria like get like $10 and then like transfer 3 of it to pay for a coffee, and then save the rest of it, and like actually get the convenience that they deserve, right? Like all of that stuff, like crypto people were talking about it. The way it was happening is basically internal Binance to Binance transfers because they're free and instant, right? So in order for like the actual decentralized chain to be competitive there, fees have to be low enough. And EIP with EIP 4844, look, we actually got to the point where layer 2s are finally there. So that's one. Then Optimism and Arbitrum have both reached stage 1, which is an important security milestone for a layer 2 protocol. It basically says that like you actually have a proof system that's like, and that proof system is actually running and actually contributing to security, right? So in an optimistic rollup, it's a fraud proof system. In a ZK rollup, it's like a Snark or a Stark. It's a validity proof system. And what stage 1 basically says is like you are allowed to have what's called a security council, like a multi-sig that can override the proof system if it has a bug. But for the security council to trigger, it needs to have a 3/4 threshold of at least 8 people, right? And so you're basically saying like you have the security council, but the security council only has like some portion of the votes. So like you're actually giving close to half of the votes to the proof system, right? And like you're basically giving, like you could think of it as being giving half the power to the proof system and half the power to the security council, right? Before this, rollups were stage 0, and so they were basically just multi-sigs. And I've talked to multiple ZK rollups that have told me that they also plan to be stage 1 by the end of the year. So big security upgrades on layer 2 protocols, many more applications on layer 2s, a lot of progress on cross layer 2 bridging. A lot of those protocols have become much faster and more convenient. Also privacy progress, right? So Railgun privacy protocol, I use it. It has a wallet, and it's like actually managed to, they've used Waku, which is the peer-to-peer network, and so like that's basically solved the problem of needing to like use IP addresses to connect to relayers. And with further progress in account abstraction, you're not even going to need relayers at all. And then you have Aztec, which is trying to be a more general purpose. And then you have Oxbow, which uses the privacy pools technology to try to provide privacy for regular users, but at the same time satisfying a lot of compliance goals. And the way that it does this is it basically has this mechanism that allows users to exclude particular other deposits from the set that basically prove that their coins do not come from a particular set of deposits, right? And so in doing so, like basically if like someone steals $50 million from a DeFi protocol and then they put it all into one of these things, like the users through automatic intermediaries called association set providers that basically just like automatically publish roots, they like everyone would just like make a proof that says that they're not the DeFi hacker, and then the DeFi hacker would not actually get any privacy, right? That's like the summary for how this works, right? And so Oxbow, it's the technology that's actually doing this. They have some very sophisticated work, and like this stuff's actually it's on I think testnet now, so pretty rapidly growing. Growing smart contract wallet maturity. So we've talked about who here is actually using smart contract wallets. Another thing that I'm excited about is ZK email, and more generally the concept of ZK wrappers as a way of bridging between like Web 2 institutional guardians into Web 3. right? So the world that I want to see is a world where when you set up a safe and you have to set up who the signers are, you can put you can put ETH addresses there, you can put ENS or whatever, but you would also be able to put an email address there. And if you put an email address there, then the interface would automatically generate an address, which is a smart contract wallet, where you can only send transactions from the smart contract wallet if you generate a zero-knowledge proof that you actually control that email address, right? And so you would be able to put in, like joe12345@gmail.com at one of your guardians, and you just passively do that. And then if you want to actually use joe12345@gmail.com to help you sign a transaction, then like they would have to like actually use the interface and then use the tool to generate the DKIM signature for the email, and then like put that into approver and generate the transaction, right? So, and like that stuff can all be obviously like done in the background with software. So this like ZK email is only one in a general class of things, right? So the Ethereum Foundation, we have a non-Adhar, which creates a ZK wrapper for India's Adhar ID system. There's a similar thing for the Mina card, which is a Japanese ID. There's similar things for passports. There's similar things for many different kinds of government ID. So basically, any like Web2 corporate or like governmental ID, you can make a ZK wrapper for it, and you can use it as an institutional guardian. Now, if you're a paranoid person and you don't want to trust the government, you do not have to do this, right? But the point is that you get to be part of the same ecosystem and part of the same network effect as other beginning users who possibly want to have some kind of more centralized approach because like they don't trust themselves to remember a 12-word seed phrase or like hold a piece of paper or whatever, right? And then also like you can start with an account where the recovery is just one ZK email, but then over time you can go and you can add more guardians, right? And you can say, okay, well now I'm going to add like some ZK email of my friend. Now I'm going to add a hardware wallet that I control, and then over time you can choose what your security setup is. And so our ability to actually do this, I think, has really increased a lot this year. Then EIP 7702, which basically unifies the EOA and smart contract wallet ecosystems from the perspective of the convenience features of account abstraction, right? So if you want account abstraction for reasons like being able to pay fees in ERC20s, like being able to send multiple operations in one transaction, so you can do a DeFi trade without like clicking approve and then clicking another thing, or you want like adapt to be able to sponsor transactions for its users, then like these are things that would be doable using the exact same code paths for both EOAs and for smart contract wallets. So that's also something that is really powerful. So a lot of progress. What are the problems today? So this is a slide that I keep coming back to over and over again, right? And I like Polymarket, and I really appreciate how it's one of those few apps that like even people who normally completely disrespect the rest of crypto and they think crypto is a bunch of stupid scams, they just casually retweet screenshots of Polymarket because it's like actually valuable information about like recent changes to like what happens in the world and what it means for other things that are likely to happen in the world in the future, right? Like even people who are just don't care about crypto at all just retweet Polymarket screenshots probably often without even realizing that this is an Ethereum application. So, but at the same time, I have to criticize this, right? So what's this? If you want to deposit USDC into Polymarket, the interface tells you you have to buy USDC somewhere, and then you send or withdraw USDC to this address on the Polygon network. And you have to send it on Polygon, not on Polygon ZK EVM. If you accidentally send it on Polygon ZK EVM, you lose your money, right? It's like how, it's almost as if you had like JP Morgan and Morgan Stanley, and they were like actually two different banks, right? Like, so the I'll admit, like I actually, I screwed up on this myself, and I ended up losing $100. I mean, fortunately, I do test transactions before I send serious money, right? But like this is tough, right? And so, like to me, this is like one of those examples of how today the Ethereum ecosystem feels like 34 different blockchains. It needs to feel like one Ethereum ecosystem. So, how do we fix this? So one big thing is address formats, right? So this is the concept of chain-specific addresses. An address should include all information needed, either to pay you or to delegate authority to you. So ERC 3770 is roughly what Gnosis Safe uses. And there's also a proposed alternative, which is basically the same information, except it puts the L2 at the end, and it uses ENS as the registry of L2s instead of having it be a centralized off-chain registry. So this is one of these things that's like actually really actively being discussed. I expect in ERC to come pretty soon. So this is one of those things, right? And so if this gets adopted and you think about this screen, you don't actually need this screen, right? Instead, all it would say is to deposit into Polymarket, send USDC to this address. And this address would say, 0xfdabd blah, 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 at polygon.eth. And you take that address and you would just paste it in your wallet, and then your wallet would just automatically figure out if you're already on Polygon, send the coins on Polygon. If your coins are somewhere else, then just automatically push them through ERC 7683 or whatever, whatever the most efficient cross-layer 2 exchange mechanism is. So that's address formats. Now, copying and pasting addresses are only one of the means by which people interact with the ecosystem. They're far from the only means, right? So in addition to this, also we want to extend ENS so that it supports similar functionality. Most of that work is actually basically already done. But this needs to continue to be deployed, iterated on, and worked. And also payment requests, right? So payment requests can be consumer to merchant, right? So for example, there's a lot of applications like Dymo, for example, that are recently trying to make Ethereum-based payment applications where you can do consumer payments, basically the original Bitcoin vision, but you do it on layer 2s, right? But the thing that we don't want is we don't want to say, in order to do payments, you all have to be on one layer 2. Right? The thing that we want is we want cross-layer 2 compatibility. And so you want payment requests where no matter which layer 2 you're on, you can say, I want this number of coins of this type on this particular layer 2, and then it's the wallet's responsibility to figure out how to route a payment so that that end result happens, right? And that could mean sending on the same chain, it could mean a cross layer 2 transfer, or it could even mean a real-time swap on something like Uniswap, or it could even mean a real-time cross-asset, cross-chain swap, right? Whatever it is, the sending wallet should do it. So, and then the other use case for payment requests is depositing to a dApp, right? So if we go back to Polymarket, well, actually, the real thing that Polymarket should be doing is it should not even tell you, copy-paste this address to deposit. Instead, you should have a button that says deposit, and then when it says deposit, it automatically just opens up a transaction in your wallet that just automatically does whatever the operation is that leads you to getting whatever number of coins you want on Polymarket. So this is also basically a payment request, but this is more of a Web3.js extension than something that would go into a QR code. So that's address formats. Then moving assets between layer 2s. Today we have custom bridging protocols. Tomorrow, standardized decentralized bridging protocols, something like ERC 7683. The reason why I like ERC 7683 is that it's super minimum infrastructure, right? As a user, all that you need to do is you just need to make a transaction on the chain that you're sending from, and you just make a transaction that basically sends your coins to a lockbox contract, and then what the lockbox contract does is it gives the coins away to whoever first proves that they actually sent you the coins on the destination chain. That proof, it might come a week later, right? And it's the job of the liquidity provider to just accept the cost and figure all of that out, right? From a user's point of view, all you need is just transaction sending capability. No linking to centralized servers, no IP addresses, no Wacro even, right? All you do is you just send transactions. And I think for any of these functionalities, there always needs to exist this maximally low infrastructure dependent, robust, decentralized, minimal base alternative. And then if wallets have some way of giving extra functionality on top of that, or even if like layer 2 sub ecosystems, like Optimism Superchain or anything have ways of giving extra functionality on top of that, they can, right? And it can be the same at the user level, but within anywhere in the Ethereum ecosystem, there needs to be like at least this base level, right? So sending tokens across chain is one, and then the other one is using tokens on any chain to pay for operations on any other chain. And there's an ERC for that also, 7755 is the name. So that's tomorrow. 5 years later, there's like some interesting, spookier ideas that you can do. So this is one that some people from ZK Sync have told me they've been brainstorming on, and I know other people have been like quietly thinking about this, but it's a super cool idea, and I think everyone deserves to know about it. Basically, you can make a token standard that has built-in batched cross-layer 2 bridging, right? So the idea basically is that imagine we're 5 years ahead and we're in this happy future world where every layer 2 is a ZK rollup, and every ZK rollup commits to Ethereum once per slot. This will take a lot of work, right? None of the existing layer 2s, whether optimistic or ZK, work this way today. But we're less far from that than you think. There are currently live implementations of a ZK EVM that can prove average Ethereum blocks in 15 seconds. And so if you think, well, can we get that down from average in 15 seconds to worst case in 4 seconds? I think yes. Like we haven't even started bringing in Binius, GKR, FPGAs, ASICs, this entire pipeline of ZK EVM optimizations, right? What we want is a formally proven ZK EVM implementation that can prove an arbitrarily sized EVM block in like 400 milliseconds times log n, and it just keeps on scaling to as many GPUs or whatever pieces of hardware as you have, right? And that's the North Star. We don't have that now. Hopefully, we will have that in 5 years. And so, okay, 5 years later, you have all these layer 2s. They're all committing to Ethereum every slot. And so let's say you have a block from Optimism that's like, I saw they're experimenting with ZK provers already, and then you have, let's say, it's sending a bunch of cross layer 2 transactions to Scroll, and what it would do is it would basically publish a receipt that just says these are the transfers that I'm authorizing that are going to Scroll, and then the token standard would itself include a zero knowledge proof mechanism by which you can basically, it can just take the receipt and it can see that the receipt was authorized by the Optimism layer 2, and it can automatically incorporate that into its balance table, right? And so you can have basically transfers from one layer 2 to another layer 2 in a way that does not use layer 1 gas per user. Like it uses O of 1 layer gas because everything uses O of 1 layer 1 gas, right? But no like extra amounts per user. And so if you have that, then like actually maybe eventually we don't even need liquidity providers. At least if you're willing to wait 12 seconds instead of waiting like 500 milliseconds. And the other nice thing about this approach is that it doesn't just work with common tokens. It also works with rare tokens. It even works with NFTs, right? Because with NFTs, like you can't do liquidity providers because like there isn't a liquidity provider that has like an extra copy of your NFT, right? There's only one copy that exists. So that's moving assets between layer 2s. Keystore wallets. So Keystore wallets, basically this is this idea that you have your wallet and you want to be able to do things like updating the keys that control the account. And so the nicest strategy for doing this today is basically you can have key update messages be automatically replayable across chains, right? And so you make the key update messages once, and then they just automatically get replayed on every single layer 2 that you're on, including layer 2s that you haven't even started interacting with. So that's the best that you can do today. But how do we make this cost less gas, right? So the way Keystore wallets work is you can keep the key information on layer 1, and then layer 2s, they will be able to use layer 1 reading opcodes. So there's two versions of this. There is L1 sload, which is something that the Scroll team is working on, and then there's ext static call, which is something that Optimism has. So basically, layer 2 can synchronously read layer 1. And so you can basically have a copy of your smart contract wallet on every single layer 2. And it's actually reading layer 1 to get the information of which public key it's verifying your stuff against, right? And so if you do that, then like basically you only need to take an action on one place in order to change your keys everywhere. So step 2 is doing it on layer 1, and then step 3 is actually, this is like, again, 5 years in the future. You have the key store on a layer 2, and that makes updating even cheaper, and that also gives you the benefit that, like, if you do all of this with snarks, then you can have, actually, you can have like zero-knowledge proof systems and changeable keys at the same time, right? So you can have a system where instead of like if your coin is inside a zero-knowledge proof system, instead of it being owned by a key, like a cryptographic key, it's owned by an address, except the location of the address is hidden. And so if you change your key, then you're automatically changing the authority for taking the coins out, right? So that's another powerful thing that you can do eventually. So today, replayable updates. Tomorrow, update and read state on L1. 5 years later, update and read wallet state on L2. Smart contract wallets. So where do we need to go, right? So gas efficiency. I mean, so now like fees are already cheaper on layer 1 and on layer 2, right? And I think one thing that people don't appreciate about blobs is that blobs, in a sense, they actually were a layer 1 gas limit increase. So this is interesting, right? Basically, what 4844 did is that it added this extra region of data space to a block called blob space. That's 384 kilobytes. 384 kilobytes, if that were in call data, then that would be 384 times 16, which is about like 6.14 million gas, right? And so theoretically, like basically, this is adding an extra 6.14 million gas, so it's about increasing Ethereum's like L1 gas in a certain sense by basically up to 40%, except it's saying this extra gas can only be used on this like specific type of data. And you can actually see this in the numbers, right? If you look at Ethereum, the actual block size, like if you go on Etherscan and you check the average block size, which includes just call data, before 4844, it was about 150 kilobytes. After 4844, it has now shrunk to being like somewhere below 75 kilobytes. Where did that extra gas usage go? It went to execution, right? And so 4844 made layer 2 significantly cheaper, and I think it also made layer 1 cheaper, also in part for this reason, right? And so now it's cheaper, and as a result, I think like we do have more breathing room to try to worry a little bit less about gas efficiency than we did before. But at the same time, we do want to build toward a future where ultimately it is efficient enough that if we go all the way back to 2021 levels of demand and then shoot past that and then do another 10x, it will still be affordable for people. Cross-layer 2 gas payments, talked about that. Chain abstraction proposals. I think, I talked a lot about some ideas, and there's also ideas around having cross-chain balances. There's a lot of these different proposals. The concept of guardians is becoming more mature. I think one of the reasons why I'm excited about the whole ZK email and ZK wrapper direction is that, like, I do think that institutional guardians are one of those things that will be required to get normal users onboarded to some kind of decentralized social recovery. And the reason basically is that the approach that I philosophically like the most, which is basically just use your family and friends. The problem is that for that to work, your family and friends have to already be crypto users, right? And so that works for people like myself, but that doesn't work for the average user. And if they try to make it work, basically what you do is you're like telling a bunch of your random friends like, hey, can you download MetaMask and then can you be my guardian? And then it turns out that 2 years later they never use MetaMask for like any other reason, and so like literally 3 out of 5 of them forget how to update their account and they lose their account, and then suddenly your recovery doesn't actually recover anymore. So this. Right, so institutional guardians I think are good, but we've spent like 10 years trying to convince people to like exchanges, other kinds of companies to voluntarily become institutional guardians. The problem is that there isn't really much of a business model in it, and so it doesn't work, right? And so what the ZK wrapper approach does is it basically takes entities that are essentially like providers of trust for other reasons, like basically that they're they're the ones controlling your Web2 account, and it uses that, like it basically lets you import that attestation into Web3. And so basically, if you use ZK email, you've basically just turned Google into an institutional guardian. If you use ZK Passport, you've turned your passport into a hardware wallet. If you use a version of ZK Passport that does like PKI all the way into the government, then you've turned the government into your institutional guardian, right? And so we basically can like take all this existing Web2 trust and we can bring it in. And by doing so, we can also actually make something decentralized, right? So like, for example, if you combine your Gmail account together with a Singapore government ID, then like you already have tech stack diversity and like you even have jurisdictional diversity, right? And then you can combine that with some keys that you control, and then maybe combine that with a hardware wallet that's like manufactured in China or somewhere else, right? So like the practical opportunity to really like get security through diversification like is something that can actually exist, right? So I think the ecosystem to actually make this whole Guardian thing possible is continuing to grow, and so I expect this to continue to become more and more viable. Types of guardians, right? So your own devices, friends and family, and then you have institutional guardians, you can have specialized guardians, and you can have ZK wrappers, right? And the nice thing is that you can basically, as a user, just choose any combination of all four. Privacy. So stealth addresses, right? So stealth addresses are basically a way to pay people in such a way that like anyone can publicly show how to pay to them, but also in a way where the payments don't like all get aggregated in one place where everyone can see exactly how many payments that they've received. So ERC 5564 is one good technology for this. Another frontier of privacy is keeping custody of user data, right? So this is one of those things that becomes important. So Railgun, it depends on holding a seed phrase. ZooPass depends on having a key. And like ideally, this should all be handled by your primary wallet, right? You should not have to like have separate wallets that do your privacy stuff and then like potentially have like two different ones, right? And one of the worries that I have is that some of these projects, they're putting encrypted data on chain as for convenience, right? So that you basically everything is still protected by your existing account. But the problem is that this basically means that all your data will become public once quantum computers come. And according to Metaculus, the quantum computers that can break cryptography are expected to come between 2032 and 2037 or so. But then I've talked to some people who think that those estimates are crazy. I've talked to other people who agree that those estimates are crazy. The problem is that those two groups think that they're crazy in opposite directions. So quantum computers are coming. I think we should be pragmatically prepared for them. So basically, there's like a lot of rabbit holes in like actually figuring out this whole user data side of the privacy conversation well. And like I think also we really continue to need much more of an explicit, well-organized privacy community, right? Like we need to, like every single Ethereum event should have like a satellite privacy summit somewhere, right? Well, I think we really need to like get to the point where things like this are a mainstay of the Ethereum community. So conclusions, right? So I think progress is being made on every front, right? We're much further along the transition to layer 2s than we were 2 years ago. We're much further along the transition to smart contract wallets than we were 2 years ago. And we're much further along the transition to having working privacy than we were 2 years ago. We're still not nearly as far as we should be in any of those three areas, and we still need to keep going. And also we need to think about these areas in context of their relationships with each other, right? Smart contract wallets have specific needs once you think about having different copies of a smart contract on different layer 2s. Raw technology is becoming more mature, right? So zero knowledge proofs, they just keep maturing every year. But we have to actually take advantage of and use these proofs inside of applications. So I think the big rallying call that I want to give to the Ethereum community here, right, is that like there is this kind of phenomenon of, like this meme of this like Linux and Android curse, right? Which is basically that like, oh, sure, like Linux and Android have their openness, but the openness is actually bad because it means there's like 20 distros that all have different standards and that don't talk to each other. I think Ethereum as a community, we should like declare war against this phenomenon and we should beat it. We should be as decentralized and open as Linux and Android, and at the same time have as consistent a user experience as Apple. And we should try hard to get as close to having 2 out of 2 as possible, right? And I think the big advantage that we have as a community is like we actually do coordinate and we actually do talk to each other, right? We actually do have entire interop events where we've literally successfully managed to have client teams talk to each other and implement very complex protocol upgrades to Ethereum for like pretty much a decade, right? Like the merge, switch from proof of work to proof of stake, happening at the same time as there being like 4 execution clients and 4 consensus clients. It happened. From the user's point of view, it happened flawlessly. And so, we can do this and we can do more, right? We can also extend this kind of spirit to the world of cross-layer 2 standardization, to the world of cross-wallet standardization and transitions, and we can like actually make Ethereum both feel like a unified ecosystem from the perspective of users, and at the same time actually continue to get all of the benefits of like having different groups that are actually go and experiment in different directions and push forward on like actually improving users' experience and giving people new features, right? As like we've already seen happen in the wallet ecosystem, as we've already seen in the layer 2 ecosystem with like Arbitrum offering things like Stylus and other layer 2s offering various upgrades and so on, right? And I think like thinking about scalability, privacy, and security at the same time is really going to be at the core of this. So thank you. Yeah, am I allowed to ask questions? Okay, sure. I guess I'll ask questions. Yeah. Okay. Mm-hmm. Yes. Yeah. Mm-hmm. 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 Mm-hmm.
So that's my point.
Yeah, I mean, I think like a lot of this technology stuff, like technology upgrades, like in a lot of ways they are playing catch up, right? And what I mean is like one example of this is how like perfect scalability in UX in a certain sense already existed from the point of view of Argentinians in 2021. It was just Binance to Binance transfers, right? And I think if you don't have the technology, then no matter what the quality of your application is, if it gets enough users, like your application by itself will just bring Ethereum transaction fees up to $50, like what CryptoKitties did. And and then everything will stop, right? I think the other piece of this is like how to bring in developers, and there's like there's like the bad way to do it and there's the good way to do it. The bad way to do it is to just say, okay, yeah, we're just gonna like throw around like $100,000 bounties and we're just gonna give people grants to like build random things on Ethereum. Right, and like the reality is if you do that, then like people will stay on your ecosystem just long enough to get the grant, and then eventually after some period of time, they'll like quietly move to the ecosystem that they actually wants to be in, right? And so I think here, like ultimately want Ethereum to be an ecosystem that's welcoming and an ecosystem that developers like wants to be on the inside of. And I think there's no single answer. I think there's a combination of a lot of answers. I mean, one of those answers, for example, is just the education piece, right? Like basically just making it easier for people who are coming in and who are interested to just get the knowledge that they need to actually start building and to figure out what are the kinds of things that that actually make sense to build. Are the ideas that they are interested in, like, are any of them actually compatible with the kinds of value that blockchains provide? And then like, how do you actually start building those things, right? So like really like having that earlier stage piece and doing it in a way that's like much more scalable than before is something that's really valuable, right? And so that's one of the reasons why the Ethereum Foundation, for example, has been supporting more and more community groups recently, right? So I think that's like one part of the answer. Another example of this is just having information be more accessible in one place, right? Like this is, like one of these criticisms that I'm aware of, right? People say that, there's all of this amazing information, but it's like scattered somewhere in different quarters of the internet and people don't really know like how to get to it, right? And like it's something that has been kind of improving. Like there's a lot of content even on ethereum.org that a lot of people don't realize exists. So actually quite a lot of good stuff there, right? But like having that kind of better information organization is also important. And then especially in a global context, having good content and also like good local mentors available in a lot of different local languages is like basically like trying to really like create stronger discourse between like various global Ethereum developer communities and the core Ethereum community, right? So I think there isn't one big answer. I think there's a lot of little answers, and like I feel like the little answers of like 2 or 3 years ago are things that the Ethereum Foundation has already made quite a bit of progress on working on. But then there's obviously like newer problems as well, and that's something where like both us as a foundation and the community needs to continue to be more adaptable.
NFTs.
Okay.
So on ordinals,
Yeah.
I've heard that NFT images
Mm-hmm.
are permanently stored on chain,
Mm-hmm.
which is why people want to store valuable art there.
Mm.
I've also heard that doing the same thing on Ethereum would be expensive.
Not anymore, because you have blobs and they're cheap.
Okay, so is it so it will be the problem solving for that thing. Okay, I will
Yeah.
research
I
more.
mean, I think like the one piece that still needs to be built out for blobs is like I think the whole conversation about like long-term history storage, right? Because I mean, like I think a lot of people have this kind of misconception that blobs are temporary and history is permanent, right? And like the reality is that actually, like this idea that every single Ethereum node is going to be responsible for storing the Ethereum history permanently, like that's actually also going away, right? There's an EIP in progress called EIP 4444 that would even like cause default nodes to stop storing Ethereum history after 6 months, right? But the other side of this is that you do not need every single node to store something for it to be permanent, right? Because like you have the hashes, right? And so you have the proof that it is part of the chain, and then on top of that, what you need is you just need to have enough nodes that are storing it that you have an extremely strong guarantee that the information will be available. And if you have if you have something like 10,000 copies of it, like that already is an extremely strong guarantee already, right? And so, like basically, there's a lot of this work around making peer-to-peer networks that could do a good job of like basically automatically backing up both the entire Ethereum history and all of the different Ethereum and every Ethereum blob, and erasure coding that information, distributing that information, and you could even have something where like as a node you could basically choose like which percentage of the chain you're storing. Right, because like if you think about it as a raw replication problem, right, 10,000 nodes that each store 100% of the data is actually just as good. It's not better. It's just as good as a million nodes, each of which only store 1% of the data, right? And so I think like we want to do is we want to move from the first to the second, right? But in order to do that, we actually need to have some of this peer-to-peer technology. And so this is also one of those things that layer 1 client developers are actively working on. Yes. Yeah.
So my question is diverting a little bit from this, but I'm curious to hear your thoughts on the intersection between Web3 and AI and how Ethereum ecosystem, crypto, and Web3 in general can solve big problems in AI.
Well, I mean, this is also something that I talked about at length with at a panel with EMAD about 3 hours ago. So hopefully that will go out on the internet somewhere. But my quick summary is I think my thesis is about the same as it was at the start of the year when I made that blog post about crypto and AI intersections, right? And one of the things that I started that post with is basically this point that like actually crypto AI intersection use cases have existed for 10 years, and they're called automated bots doing arbitrage and market makers, right? And what I think is interesting about that example is that it really like shows an entire category. And that entire category is what I call an AI as the player in the game, right? So what blockchains are good at is they're good at defining the rules of the game. They define the set of permissions, authorizations, incentives by which participants can interact and then motivate how participants interact with a system. Now, a lot of the time, these for these things to be efficient, you still need to have high-quality participants, right? It's like a prediction market is only as good as the quality of people that are actually part of it, right? Which I think is a big part of the reason why, like, I actually think like Polymarket is pretty good now, but I'm willing to admit that like it made huge mistakes back in 2020, and like I was able to like make $58,000 betting against those mistakes, just by playing a really basic strategy of buying the same thing over and over again, right? So the tie-in here, right, is like if you zero in on prediction markets specifically, like what are they, right? They're a primitive for converting a high fidelity but slow signal into like basically a lower fidelity but much faster compression of that signal, right? And so one of the things I'm excited about is micro prediction markets. So for example, take Twitter community notes. A lot of people, I think, like really like Twitter community notes, and the reason is that like it's one, it's a fact-checking mechanism, and so it actually does like call out misinformation and false statements, and like it gives a lot of really valuable clarifying context. But two is like it's something that obviously isn't playing for any one team, right? Like, you know, when it goes into U.S. politics, like sometimes it makes Republicans look like idiots, sometimes it makes Democrats look like idiots. Then if you get into international stuff, it makes like pretty much every geopolitical team look like idiots at least sometimes. And then this is one that like you really have to give praise to Elon for, right? He lets community notes go on ads, right? So you literally have like advertisers that are paying Elon for the privilege of getting a tweet into everyone's faces saying, hey, here's a thing, you go to this website and you can buy this lovely product for $24, and then like Elon lets you just like put up a community note there that says, hey, this is actually a drop shipping thing. If you go to this other link on AliExpress, you can get it for like $4.25, right? And so like it even goes after the corporations, right? Now, that's the good side of it. The bad side of community notes, I mean, people have different criticisms, but by far the largest one is that it's too slow, right? And like sometimes you have a post that gets to like all the way to 3 million views, and it gets to 3 million views, and it's like something completely crazy before a community node even comes up, right? And so what can you do? Well, one possible solution is to basically stick a prediction market on top of it, right? So imagine something where, someone puts up a crazy tweet and like it makes some crazy accusation about like some group eating cats and dogs or like whatever, right? And then, like literally within 30 seconds, you can see, like some like yellow marker that says, like prediction markets that LLMs are playing on think that there is an 85% chance that this will be considered misleading by a vote of users within 1 week. And so then you have these different LLMs that are playing, but then what motivates the LLMs? Well, if on average they're correct, then when the market resolves, they win. If on average they're wrong, then when the market resolves, they lose, right? And so over time, you're basically like automatically selecting for LLMs that actually do a better job of making these predictions, right? And so you're able to like make something that has like the quality of AI models and even AI models using private information, but that is at the same time an open protocol that has an incentive that signals toward quality. So this is like one of those categories. And to me, this is like basically AI is participating in crypto, right? The other side of this, I think, is like crypto participating in AI, right? And so here, the challenge is basically that, we've seen a lot about the value that AIs can provide, but the thing that we don't see, or the other thing that we see is some of the challenges around AI models being centralized, around AI models having these like very opaque biases where we don't know how they're trained, we don't know, like what the underlying process that fine-tunes them is. There's even the possibility of like making attacks against where during the training process you can insert bugs that can cause the model to start doing crazy things if particular inputs happen, right? So there's like all these different issues. And the question is like, well, can we have like open models, and can you try to make training processes more trustworthy? And also, can you try to make AI inference be either more trustworthy or more privacy preserving, or both, right? And these are things where cryptography, right? So things like ZK snarks, multi-party computation, FHE, those kinds of things can potentially help, right? And one of the reasons why this is a little bit less crazy than it seems is because if you look at the details of what an AI computation is, basically most of it is matrix multiplication, right? Matrix multiplication is expensive. It's O of n to the 2.7, right? But matrix multiplication is linear, and linear computations are extremely amenable to all kinds of mathematical tricks for making proofs of them or doing them privately. There is still a nonlinear piece, and the nonlinear piece still ends up being like basically the bulk of the cost if you're doing it cryptographically. But the overhead is still like much lower than it would be for actually general purpose computation, right? And so I think like that whole space of trying to do AI within various forms of cryptography and then either doing like proofs over training or doing private inference or doing proofs over inference or doing private provable training or like any of those things, like I think there's value in all of those directions that's also really worth exploring. And I think that kind of stuff, like it also makes sense, like for AIs that are themselves doing things within the crypto ecosystem, right? So like, for example, WorldCoin has been looking at this a lot because, like they need the AIs that are doing like detection of whether you're looking at an actual face or like a 3D fake model, and they want that stuff to be trustworthy so that people other than WorldCoin can be convinced that there aren't like 50 million fake people somewhere. And then if that technology works well enough, then like you can even start applying it to models that are being used in places outside of crypto as well. Okay, someone back half of the room. There, back row.
And we'll take that one last question,
Yeah.
and then I think we need to
Perfect.
wrap up.
How do you envision democratizing the example a while ago about proof of personhood, about democratizing guardian for families and friends, for them to be able to understand, let's say, can they create a wallet even though they don't know what is a wallet, etc. So how do you envision that?
Yeah, I think, to me, like, one very successful example of social recovery that I keep coming back to is the way that recovery works in WeChat, right? So in WeChat, at least back when I was using it, right, there was this feature where what you can do is, like if you lose your account and you're recovering it, one of the things that it asks you to do is it asks you to ask 2 of your contacts to send a 6-digit code to your account, right? And like this basically is a form of social recovery, right? And like that is a form of social recovery where like you could actually implement something that works in exactly the same way, except under the hood, it's all blockchain based, right? And so I think you can make implementations of all of this stuff where, like, under the hood, you can look at the code if you want to look at the code, and you can actually see that it's doing all of these social recovery-based things. But from the perspective of UI, it doesn't actually look all that technical. It just looks like a type of interaction with your friends. Yeah. I think that was the last one, I think. And like, this is Singapore, so we have to, like, actually follow rules here, so...
Thank you so much. Thank you again, Vitalik, so much for joining us. Thank you, everyone, for joining us for the Web3 Transitions Summit. I hope you return energized and inspired, and see you again next year.